Listen to part of a discussion in a geology class.
Hoodoos are tall, thin spires of rock that rise up from the basins in high plateau regions such as the Colorado Plateau or the Badlands. This is an example of a hoodoo. As you can see, the shape's irregular. What you may not perceive from the picture, though, is that this hoodoo's about the height of a 10-story building. But what causes these fantastic structures? How do they form? Anyone?
Doesn't it have something to do with the way that the rocks weather? I think there are different minerals.
Exactly. About 30 or 40 million years ago, there was a lake bed here, and minerals were deposited in it. So although most of the hoodoo is limestone, and as you know, limestone is white, the colors in the layers of limestone are created by small deposits of iron that oxidize to produce shades of yellow, orange, red, and brown. Manganese oxides create the blue and purple tones, and then the weather and light conditions also contribute to the variety of colors that you see in the canyons. But you said that the rocks weather. Do you want to expand on that?
Okay, well, I mean that the water, the rain and snow, they cause erosion.
So water plays the major role in creating the landscape, like you said. But to really appreciate this, you have to understand two processes: mechanical weathering and chemical weathering. Anyone remember the difference between them, the two processes?
I think mechanical weathering is another name for frost wedging. I remember the example in the book, the one about what happens when a crack opens in a paved road and then the water freezes and it expands. I think it expands about 10%, and bit by bit it pries open the crack and makes it even wider.
Right. Thanks for bringing up the example of the road. On about 200 days every year, the temperature rises above freezing during the day and then drops down below freezing at night. And during these freezing and thawing cycles, water seeps into the cracks in the rocks and expands during the freezing, which breaks the rock into smaller pieces. When the ice melts, the pieces fall apart, and the water washes them into the canyon. So this is mechanical weathering, or to be more specific, frost wedging. Now, in addition to frost wedging, chemical weathering also breaks down the rocks. How does that happen?
Isn't chemical weathering, doesn't that happen because water absorbs weak acids from the air and soil, and that dissolves the calcium carbonate, which was a kind of cement to hold the clay, the silt, and the sand particles together. So when these particles fall into the canyon, they help shape the formations too.
That's a good summary. What little rain we get here also creates the hoodoos. It's slightly acidic, the rainwater. So this weak carbonic acid can slowly dissolve limestone grain by grain. And it's this process that sculpts the hoodoos and gives them their unique profiles. Where internal mudstone and siltstone layers interrupt the limestone, you can expect the rock to be more resistant to the chemical weathering because there's comparatively less limestone. So each type of rock erodes at a different rate, carving out the formations. Just suppose that one of the pillars is composed primarily of sandstone and ironstone. Well, the sandstone will certainly disintegrate faster than the harder ironstone, and the result will be an unevenly shaped pillar, a hoodoo. This is a fairly typical process for the formation of hoodoos. As you can see, first, you have a plateau that weathers into what we call a fin. As the weathering continues, a window breaks through the fin, and eventually, a series of windows allows the hoodoo to break off into a freestanding structure. Okay, many of the more durable hoodoos are capped with a special kind of limestone called dolomite. Dolomite is fortified by magnesium, a mineral that dissolves at a much slower rate, and consequently protects the weaker limestone underneath it. Let me show you an example of that. The dolomite cap, I mean. See how the cap protects the limestone underneath? As you can imagine, without them, the limestone would erode and the hoodoos would disintegrate.
Excuse me, I have a question.
Go ahead, Pat.
Well, what about wind? Wind erosion.
Oh, I see what you mean. Now, I know that a lot of rock formations are carved out by the wind. But in the case of hoodoos, wind has very little to do with it. For one thing, we know that in most areas where hoodoos are prevalent, such as Bryce Canyon in Utah, there's no pattern of erosion for the dominant wind direction. If wind were responsible for the hoodoos, then they'd erode in a parallel formation with the prevailing wind direction. But they don't. In addition, the surfaces of the hoodoos would be rounded and smoother if wind were responsible for creating them, wouldn't they? But many hoodoos have sharp edges and jagged tops. These uneven angular shapes are a big clue that it's water, not wind, that created these unique formations. So now we know how hoodoos formed. But unfortunately, hoodoos aren't very stable. So as you can probably imagine, the same processes that create hoodoos are equally aggressive in destroying them. The average rate of erosion is calculated at 2 to 4 feet, 0.6 to 1.3 meters every 100 years. And in any one location, you'll see both the formation and destruction of hoodoos at different stages in their development.